What we are really talking about here is a new way Angular handles states. With Angular version 16 and above, we got something called signals. And the most important thing to understand here is this. They are not just another utility. They are a new reactive primitive built into Angular itself. Now, why does that matter? Because historically, if you want to manage state in Angular, even a simple UI state, you always end up reaching for RxJS. And RxJS is very powerful. But let's be honest. For something like toggling a button, selecting or tracking a selected row, or updating a small piece of your UI state, it feels like overkill. You end up dealing with subscriptions, cleanups, and more structure than the problem actually needs. Signals are Angular's answer to that problem. They are designed to simplify your UI-driven state. So instead of thinking in terms of streams and subscription, you just think private value. When it changes, then the UI should update as well. That's it. Now, for the real interesting part, and this is the key takeaway on signals, and that is a fine-grained reactivity. What that means in practice is Angular no longer has to recheck large part of your component tree when something changes. With Signal, Angular knows exactly what depends on what. So if a signal changes, Angular doesn't just go, let me check everything in this component just in case, but rather it goes, only a specific UI binding depends on that signal. I will update that. And that's a big shift. It makes updates more efficient, and more importantly, it makes the mental model simpler. You're no longer guessing what will be re-rendered or when will change detection kick in. So, if I had to summarize this tutorial in one sentence, it will be: Angular signals are Angular's move towards a more direct, a more predictable, and a more efficient UI reactivity without the overhead of RxJS for simple state. The reason Signal exists really comes down to the core issue in traditional Angulars. That is, change detection is too broad. In the classic Angular model, when something changes, Angular doesn't always know exactly what changed or what depends on it. So, what does it do? It runs change detection across large parts of the component tree, sometimes even the whole tree. And that's fine for small apps. But in a real-world application, especially large ones, that can be inefficient. What you're doing is that you're essentially rechecking a lot of UI that didn't need to be rechecked. And on top of that, Angular has historically relied on Zone.js, which patches async operations in the browser. That's how Angular knows something might have changed. Better run change detection. But again, it's a bit of a blunt instrument. It doesn't track what changed, just that something has changed. So you end up with a system that works, but not always precise. Now, this is where Signals comes in and change the game. Signals introduce automatic dependency tracking. That means Angular knows exactly what part of the UI depends on which piece of the state. So instead of saying something happened, recheck everything just in case, Angular can now say this specific signal changed, so only update the UI that depends on it. And that leads to two big improvements. First, only what actually changed gets to be updated, no unnecessary work. Second, you get fewer unnecessary re-rendering, which improves performance and makes the behavior more predictable. So, if you zoom out, signals are essentially Angular moving from a broad zone-driven change detection system to a precise dependency tracking reactivity system. And that's the key shift: less guessing, more precise, and far less wasted work. So when we talk about the key capabilities of signals, there are three main building blocks that you need to understand. These are what makes the whole system work in practical Angular application. First up is a writable state or signal. This is your basic unit state. You can think of it as a value container that Angular is tracking. You can read from it and update it directly. So instead of managing state through services, subjects, or subscription, you simply define a signal and mutate it when needed. It's your simplest form of reactive state. Then we have derived state or computed. This is where things start to feel powerful. A computed signal is a value that is automatically derived from another signal. So instead of manually recalculating values or subscribing to changes, Angular does it for you. If any dependency changes, the computed value updates automatically. You can think of it as this value is always a function of other value. And importantly, it stays in sync without you writing any extra glue code. Side effects. This is used when you need to react to changes, not just calculated values. So things like logging, calling a service, updating local storage, or triggering external behavior. Whenever the signal inside an effect changes, Angular reruns that function automatically. So it's basically when the value changes, run this logic. And the final piece, and this is really the core strength of the whole system, and that is automatic dependency tracking. You don't manually subscribe, you don't wire dependency together, you don't manage cleanup. Angular does all of that for you under the hood. It tracks which signal are read from during execution, builds a dependency graph automatically, and then uses that to determine exactly what should be updated when something changes. So if I summarize all these in one line, I would say signals gives you state, derived state, and side effects, all with automatic tracking and no manual subscription management.